In this video, we are going to discuss about von Neumann architecture. So this was drafted in the year 1945 by John von Neumann, and this architecture is also called as Princeton architecture. This architecture is based on the stored program concept. Here, the program data and the instruction data is stored in the same memory. So that is why it is called as stored program concept. So this is with the help of this model only the modern computers are made. So how this architecture will look like means you have an input device, output device, and inside the CPU you have ALU and control unit, and the memory is outside. We can access the memory. Okay, so the advantage of so what is input device, right? So in keyboard, joystick, mouses and all comes under the input device. If any key is pressed, the system will detect the ASCII key will get converted, and it will be processed by the CPU, and it will be displayed in the output device, right? The output device here is a monitor. If you want to get it in the hard copy, you can use a printer. So this comes under the output devices. ALU means arithmetic logical unit. The arithmetic operation means addition, subtraction, multiplication, division, and all comes under arithmetic operations. And logical operation means whichever it uses the gates, like logical gates like AND, OR, NOR, XOR, XNOR, and that comes under logically operations. So what is the role of the control unit here is so it will instruct whichever the operation has to be performed. Okay, so the memory is, right? The memory is to store the data, and whatever the program, whatever the instructions, everything gets here the OS and all, it will be stored only in the memory. This von Neumann architecture is suffer from a problem called bottleneck. So it will limit the performance of the CPU because it uses a stored program concept. So since it uses a single buses, so the single buses is used for instruction fetch and also for the data operation, so which cannot be occurred at the same time. Therefore, for executing a single instruction, it will take more than one cycle. So that is a problem of von Neumann architecture. So not to avoid this problem only, we are going for Harvard architecture. So where in the Harvard architecture we use a separate bus for instruction fetch and separate bus for the data operation. So how to avoid this bottleneck problem is it can be avoided by using a cache between the main memory and CPU, and if you use a separate access for the data and instruction, we can avoid this problem. So this comes under the modified Harvard architecture, this type of and we can use as a branch predictor algorithm. So if you see what are the advantages of a von Neumann architecture, means it is very simple, because since it uses the stored program concept, whereby all the data and program and instructions are present inside the same memory. It is very simple. Why? Because we don't require any further component, right? More component. Therefore, it is cost effective, and it offers very good flexibility. So what is flexibility means? Here the program can always be change or alter without experiencing a change in some underlying physical aspects such as circuitry. And what are the disadvantages? Bottleneck issues, as I already told you. Here, uh, we don't have any separate bus for data and instruction fetch. Since it is cannot be performed simultaneously, this is very slow in operations. So what does memory corruption means? Suppose if the data and the instructions, the programs are stored in the same memory. If somebody uh, erase any content means it will be goes to it will uh, make the system fault, right? So this is a disadvantage of von Neumann architectures. So if I compare the von Neumann architecture and the Harvard architecture, the cost wise, von Neumann architecture is very less compared to the Harvard architecture. And the uses of this von Neumann architecture is it is used in the personal computer and also in the small computers. Okay, so whereas if you see the Harvard architecture, it is used in the microcontrollers and signal processing and all, because we are using a separate bus for the data transfer and the instructions, and the instruction can be executed in a single cycle. It will be costlier, and most of the modern computer architecture is based on the Harvard architecture. Okay, and since you are using a separate bus for both instruction and so the parallel processing can also be achievable with the help of the Harvard architecture. So therefore, the von Neumann architecture based computer have the following characteristics, like it utilizes a single processor and it utilizes one memory for both instructions and data, and implement the program by executing one instruction at a time. So here the parallel processing cannot be done. So if you see this John von Neumann is a famous mathematician um, who wrote the first draft of a report on the ED fact. So the conclusion is this architecture is based on the store program concept. So here I have this type of components like input, output, CPU. In the CPU, in addition to that one, you have registers. Okay. Then so this fundamental concept is almost more than 70 years old. Okay, so therefore it has its own advantage and disadvantage. So I hope this video is useful for you. So for in order to study the further concept, you refer to my other videos. Thank you.